For station 2, we're going to be estimating and simplifying radicals. I'm going to be using this multiplication as a tool. This multiplication table is also available on the top toolbar of your practice test and also your test. Okay, so let's start with estimating. When I estimate to the nearest tenth, what I'm looking for is, look, like this, if I take the square root of 4, it's 2. If I take the square root of 9, it's 3. If I take the square root of 16, it's 4. If I take the square root of 25, it's 5, and so on, right? But if I take the square root of one of these numbers that's like in between, then that's where I have a decimal. So the square root of 54, look, it's in between, 54 is in between 49 and 64. So 54 is in between the square root of 49 and the square root of 64. So the square root of 49 is 7, and the square root of 64 is 8. So 54 is in between. If I take the square root of 54, it's going to be in between 7 and 8. Now, where? Let's see, 54. Where's 54 between 49 and 64? Let's see. 54 is, like, I can just use my fingers, right? Like 50, 51, 52, 53, 54. It's 5 more than 49, and I can see it's 10 less than 64. So it's a little closer to 49. It's not right next to 49, but it's definitely closer to 49 than it is to 64. So I'm looking for a number that's like here. Like it's in between 7 and 8. It's definitely closer to 7 than it is to 8. I would say, like, I don't know, this is maybe like 7.1, 7.2, 7.3, 7.4, 7.5, something like that. I would estimate this at around 7.3. All right, let's look at this one, square root of 80. Now, the square root of 80, this one, like, to me, this one's easier, and the reason is the square root of 81 is 9. So the square root of 80 is like, oh, it's just below 9. Like, what number is just below 9, right? Like, this is going to be a number that's in between 8 and 9, and it's like super, super close to 9. It's just below 9, and that number would be 8.9. Right? And I could draw it out like this, but I don't need to. Like, these ones that are really close to one of my perfect squares are just a little bit easier. Square root of 45, let's see, square root of 45 is in between 36 and 49. This is another one that's not super close to either side, so let's just write this out and get a good handle on it, right? The square root of 36 is 6, and the square root of 49 is 7. So this is going to be somewhere in between those, and square root of 45 is definitely closer to the square root of 49, right? 45 is closer to 49. It's not right next to 49, but it's like, I don't know, maybe like here, right? It's definitely closer to 49 than it is to 36. So if here's 6 and here's 7, I'm looking for a number that's between 6 and 7, and it's definitely, you know, closer to 7. And so I would say, like, this is like 6.1, 6.2, 6.3, 6.4, 6.5, 6.6, 6.7, 6.8. I would call this like 6.7 or 6.8. I would go with maybe like 6.8 here. Right, and I would definitely accept 6.7, and probably here even like 6.6 I would say is correct, right? Like where there's a little flexibility with the estimating, but you need to recognize that this is between 6 and 7, and it's closer to the 7. All right, square root of 17. This is another one that's really close to one of my perfect squares. Like the square root of 16 is 4. So what's a number that's just a tiny bit more than 4? 4.1. Okay, square root of 120. Here's another one that's nice and close. Look, the square root of 121 is 11. So the square root of 121 is just below 11. Sorry, square root of 120 is just below 11. That would be 10.9, right? That's like tiny bit below 11. All right, that's estimating. Let's simplify. I'm looking for two numbers that multiply to 54. If you don't have these memorized, right, you can feel free to use these. I'm looking for the number 54. Oh, here it is. 9 times 6 is 54. Right, and I can do this, that's prime, 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 and prime. So when I set up to simplify this, it looks like this. And remember what I'm doing is I'm looking for doubles. Why am I looking for doubles? Look, let's write this one out the long way so you have it. I'm looking for doubles because the doubles simplify. So notice the doubles went in their own house, and the singles are gonna go in their own house. These doubles, look, like think about what this means. This is 3 times 3, which is 9. And the square root of 9. What's the square root of 9? Oh, the square root of 9 is just the number 3. You could also view this as, this is 3 squared and square rooted. And if you remember from, if you did station 1, right, we know that square and square root are inverse operations. And so, for sure, if I square a number and square root it, I just end up with that number back. Now here, this doesn't simplify, right? This is going to be the square root of 6. This is one of those ugly numbers that's not something that I can simplify. And so what I do is I just leave it. 3 times 2 is 6, and I just leave it just like this. Okay, let's try this one. This one feels, way more complicated. The math itself is not more complicated, but what is more complicated is just keeping organized. And so notice I've given you plenty of space here. So let's go ahead and use the space. Okay, now what I'm gonna do is I'm just gonna focus on what's inside here. So this 7 times a squared times b, I'm gonna put it here, and the reason is because otherwise I'm gonna forget it, but I'm gonna focus just on simplifying what's here, okay? And what's here is 3 times 3 times 2, that equals 18, times A times A times A times A, times B times B times B times B times B. And I'm looking for doubles. Oh, this is not a double. Oh, there's a double, there's a double, there's a double, there's a double. Ooh, that is not a double. All right, so now, remember this 3 times 3, the square root of 3 times 3, becomes just a 3, the same way it did here. So this just becomes a 3. Look, this just becomes an A, right? This just becomes an A. This becomes a B. This becomes a B. And then what's left inside is the things that don't simplify, which is my singles. That's that 2 and that B. And now all I have left to do is just make this look not so crazy. Okay, so 7 times 3 is 21. This is A times A times A times A. There's a total of 4 A's out here. Okay, and notice the big thing that happens is we forget like these ones. Okay, so I just really like this strategy of just everything's just written all in one row. Some of you kind of like to do this in bits and pieces, and I just feel like it's really easy to make mistakes that way. Let's look at the B's. This is B times B times B. That's a total of 3 B's. And what's in here doesn't get simplified or combined with anything. It just stays in there, and it looks like this.